Today, we're diving into a really simple but incredibly powerful calculation that is absolutely essential for keeping our water safe. It's a true cornerstone of environmental engineering, so let's jump right in and see how it works. This is the big question, right? We build these massive, complex treatment plants, but how do we actually know if they're doing their job? How do you put a number on clean? Well, it turns out engineers use a surprisingly straightforward tool every single day to get that answer. So let's take a look at how they do it, how they actually measure clean. It's called percent removal, and you can honestly just think of it as a report card for the treatment process. It gives you a grade, telling you exactly how well the system is getting rid of specific pollutants. And this isn't just for tweaking the process. This number is critical for proving you're in compliance with environmental regulations. Okay, so how do we calculate this grade? Well, it all comes down to a really simple, totally logical formula. Okay, here's the whole thing. First, you measure how much of a pollutant is coming into the system. Then you measure what's left of it going out. The difference between those two numbers, that's the amount you successfully removed. Then you just divide that by the original in number to see what fraction you got rid of, and finally multiply by 100 to make it an easy percentage. That's it. In minus out divided by in. Simple, right? All right, theory is one thing, but let's see how this formula actually plays out in a real-world treatment plant. So here we have a primary clarifier. Its main job is to let solid gunk settle out of the water. The incoming water, the influent, has 200 milligrams per liter of what we call total suspended solids, or TSS. After it goes through the clarifier, the outgoing water, the effluent, only has 80. So what's the percent removal? Boom! 60%. We just follow the formula. 200 coming in minus the 80 going out leaves 120 that was removed. Divide that 120 by the original 200, and you get 0.6. Multiply by 100, and there you have it, 60% removal efficiency. See? That's how it's done. And this calculation isn't just for one little piece of equipment. Oh no, it's used to measure the health of the entire system, from the moment water enters the plant to the final discharge. And operators have two main ways to approach this. They can measure based on concentration, that's the milligrams per liter we just used, which is perfect for quick, daily, how are we doing checks. But for the big, official regulatory reports, they often calculate the total mass of pollutants in pounds per day. It's the exact same formula, just with different units, and it gives you that bigger picture view of the plant's total impact. And you see this formula applied at every single stage. A primary clarifier, it's shooting for 50 to 70% TSS removal. Then you get to secondary treatment and the standard jumps way up. You need upwards of 90% removal of something called BOD, which is a measure of organic pollution. To meet EPA standards, the entire plant has to remove at least 85% of both TSS and BOD. It's a tough bar to clear. So we have the numbers, but what do they really mean? This is where that simple math translates into critical, real-world action. When you get a high positive number, like that required 85% or more, that's the sign of a healthy system. It means a ton of pollutants are coming in, very little is going out, and the process in between is working beautifully to clean that water. At the end of the day, a positive result just means removal is happening. It means the water leaving the plant is cleaner than the water that came in, and that, of course, is the entire goal. But what happens when you get a negative number? That is a massive, flashing red light. It means more pollution is going out than came in. The process isn't just failing, it is actively making the water worse. It's a critical warning that something has gone deeply, deeply wrong. A negative number can be caused by all sorts of serious problems. The biological process might just be failing. You could have an issue called sludge bulking, where solids that are supposed to settle are instead washing right out of the system. Or maybe the water is finding a shortcut, just bypassing treatment altogether. It could even be something simple, like a bad sample, but you have to investigate immediately because the stakes are incredibly high. So the formula itself is simple. But getting a bad result, a negative result, points to these incredibly complex failures in biology, chemistry, and engineering. It's just a single number that can signal this cascade of problems in a system that's designed to protect all of our health. The real question isn't about the math, is it? It's about the unbelievably intricate systems that keep our water clean.